This whole lesson is actually going to be a lot like 4.2, where we were just adding and subtracting rational functions or rational expressions, except that what we're going to have is, adding and subtracting them, but then they'll be set equal to something. So we have an equation now. So your steps in how to solve these, same thing as in 4.2, get your common denominator by finding your least common multiple. You want to write a new equation using only the numerator. So once your denominators match, you'll write the new equation, solve it, and then always check your answer. And so the reason that we want to check the answer is because we have what's called extraneous solutions. And what that means is that you get the number for a solution, but it doesn't actually work in the equation. And maybe even say original equation. Okay, so we need to check for extraneous solutions. It's really super important that we do that. So let's go ahead and look at the very first example. So 2 over x plus 3 over 2 equals 19 over 10. And so all we want to look at right here is x plus 3, 2, and 10, and we want our least common multiple. Well, we can't factor this, so this just stays as it is. And then 2 and 10, there's nothing we can do with those either. But 2 and 10 they both go into 10, and then we have the piece of the x plus 3, so one piece of everything from the denominator. So this is what we're going to make our denominators become. So I'm going to take that 2 over x plus 3, and we need this 10 piece to be a part of this first fraction. So we're going to multiply by 10 on the top and on the bottom. Here we have 3 over 2, but we need it to have a 10 and also an x plus 3. Well, since it already has a 2, we only need to multiply by 5 in order to get 10, and then we also need the x plus 3. So whatever you do on the bottom, you must do on the top as well. And then set that equal to 19 over 10, and what are we missing here? That would just be the x plus 3 piece, so we'll do x plus 3 top and bottom. So our first fraction is now 20 over 10 times x plus 3, plus, I'm going to go ahead and multiply the 3 and 5 on the outside, so 15 times x plus 3 over 10 times x plus 3 equals 19 times x plus 3 over 10 times x plus 3. So now that our denominators match right here, so notice how all these denominators are exactly the same, we get to ignore them and just work with our numerators. So I'm going to write a new equation now and use only the numerator portion. So 20 plus 15 times x plus 3 equals 19 times x plus 3. And then we just have to solve it. So go through the motions and do your distributive property first. So 20 plus 15x plus 45 equals 19x plus 57. Combine your like terms, 15x plus 65 equals 19x plus 57. I'll go ahead and subtract 15x from both sides of the equation. So we get 65 equals 4x plus 57. And then subtract 57 from both sides of your equation to end up with 8 equals 4x, and then divide by 4 to get x equals 2. So remember that there's a chance that this could be extraneous, so we need to check it. You always need to check it. So we're going to go ahead and plug in from the original. So 2 over 2 plus 3 was the first fraction, plus 3 over 2 equals 19 over 10. And so from here we have 2 over 5 plus 3 over 2 equals 19 over 10. Well, we need a common denominator in order to add those together. So I'm going to multiply the top and the bottom here by 2 and over here by 5. So that way we get 4 over 10 plus 15 over 10 equals 19 over 10. Add them together, and you get the same thing on both sides. So it is actually a solution. It worked. So then you come back to this x equals 2, and this is your solution. Okay? All right, just one more problem. So getting our least common multiple here, again, this would be a matter of factoring. So looking at your denominators, x minus 5, there's nothing that we can take out of that. It's just x minus 5, and we can't go any further. Same with the x minus 4. It just stays as x minus 4. But x squared minus 9x plus 20 is actually x minus 5 times x minus 4. So our least common multiple for this problem is going to be one piece of everything in the denominator, which is x minus 5 and x minus 4. So looking at this fraction then, our very first one, what is it that it's missing? Well, it's got the x minus 5, but it doesn't have x minus 4. So we need to go ahead and multiply top and bottom by x minus 4. Subtract from that 9 over x minus 4, and that would be missing x minus 5. So multiply top and bottom by x minus 5 equals 5 over x minus 5 times x minus 4. So when you go and multiply, we end up with 8 times x minus 4, and I'm just going to leave it as that for now. And you'll notice that all of the denominators come out to exactly the same thing, which is what we want to happen, because that way we can ignore the denominators and just solve the equation using the numerators. So, oh my gosh, I can't draw. There we go. X minus 5, x minus 4. So looking at this right here, noticing that these are all exactly the same, which is what we want, we get to ignore them now altogether and just look at our numerator. So write your new equation now of 8 times x minus 4 minus 9 times x minus 5 equals 5. Distribute 8x minus 32, and then remember here that the sign comes with the 9, so minus 9x, and then plus 45 equals 5. Combine like terms, so 8x minus 9x is a negative x, and then negative 3 plus 45 is 42. And subtract 42 from both sides of your equation to get negative x equals a negative 37. And then go ahead and get, oh my gosh, I didn't write 32. Oh my goodness gracious, y'all. I just totally screwed that up. This is 32, which means, I'm so sorry. Gotta fix it. Rewind. This is what happens when you just get cruising. 32, there we go, minus 9x plus 45 equals 5. Combine your like terms, so negative x, and then we get plus 8 equals 5. Or 13, oh my god. Plus 13 equals 5. Subtract 13 from both sides of the equation to get negative x equals negative 8. Divide by a negative 1 because you want to solve for a positive x value, and you get x equals 8. All right, actually I should not box that in. I should be careful with that. So x equals 8, and then we have to go back and always check. You have to make sure that it actually works. So 8 over, and I'm going to plug in 8 for x, minus 5, minus 9 over 8 minus 4 equals 5 over, and this would be 8 squared minus 9 times 8 plus 20. Let me make sure I have that right before I move too far ahead. Yes, okay. All right, so now we need to go ahead and simplify as much as we possibly can. So we end up with 8 over 3 minus 9 over 4. And this isn't really necessary right here. And over here, we end up with 5 over 12. And a common denominator here would be 12, so I'm going to go ahead and multiply this by 4 on the top and bottom, and this one by 3 on the top and bottom, so that we end up with 32 over 12 minus 27 over 12 equals 5 over 12. And when you subtract these two, you get 5 over 12 equals 5 over 12. And since that does work, that means we do have a solution of x equals 8. It is not extraneous. It does in fact work. And there you go.